All right, so now we're looking at graphing polynomials. So the first thing we need to know about the graph of a polynomial is that the graphs of polynomials are smooth. So what that means is that I can draw it without ever lifting my pencil up. And there's also going to be no corners. So a corner, like if we had an absolute value graph where it sort of makes a V, then we don't have that with an absolute value graph. Let me change my pen width here. Okay, so we talk about polynomial functions increasing. So as x increases, if my y value is increasing, then I say the function's increasing. As x increases, if the y value is decreasing, then I say that the function is decreasing. And I talk about the intervals that happens on. So here I would say f of x is increasing for x less than -2. Between -2 and 1, the function is decreasing. And then for x greater than 1, it's increasing. Right at the point where it stops increasing or decreasing, that's not included. So that's why we have x less than 2, -2 less than x less than 1. Those points where it switches from increasing to decreasing, we call those relative maxes and mins. So here, we don't have an absolute maximum because our graph continues to increase forever, continues to decrease forever, so that's why we call it a relative max and min. The word to refer to them together, the plural of that, is extrema. Once we get into calculus, we'll talk about them more and find ways to find them algebraically using calculus, but right now we're going to use our calculator to help us determine the maxes and mins. We can also refer to these as turning points. We also talk about the degree of a polynomial. So the degree of a polynomial, we've seen before, the degree is the highest power of x. So x to the n plus x to the n minus 1 plus all the way down until we have a constant. Well, I say that this is an nth degree polynomial. And so at most, it will have n zeros. So it will cross the x-axis at most n times. The number of maxes and mins will be at most n minus 1. So let's think of an x squared graph. That looks like this. So it's possible that I'll have 2 different roots, and I'll have only one extrema. If I have an even graph, like x squared, so if my degree is even, not if the function is even, but if the degree is even, it may or may not cross the x-axis. So it could be that my parabola is above the x-axis and never crosses. We've also seen where we could just touch once, or we can touch twice. However, if it's an odd degree, I will always cross the x-axis at least once. And that's because for an odd degree, like a cubic, I will start increasing, maybe have a section where I decrease and then increase again. So if I start and end increasing or start and end by decreasing, I'm always going to cross the x-axis. And I could end up crossing the x-axis as many as 3 times. So 1, 2, 3. Or I could cross just once. My leading coefficient test tells me which way the graph, helps describe the end behavior of a graph. So if a is positive for an odd function, I start and end increasing. If a was negative, I start and end decreasing. And we can think about this with a quadratic. Here, my a is positive. I start decreasing and end increasing. Or I can think of it as pointing up on both sides. If a were negative, I would be pointing down. So my leading coefficient, along with whether my degree is even or odd will help me figure out the end behavior. So odd degree functions start pointing up, end pointing down if A is negative, or start pointing down, end pointing up. If it's even and A is negative, I start down and end down. If A is positive, start up and end pointing up. So I'm going to stop there and we'll come back and put this all together with examples.